Hello everyone. So in this video we are going to see the further details of scanning electron microscope, which is a totally different imaging concept. Now instead of using this full field image, a point to point measurement strategy is used. A high energy electron beam is used to exit the specimen and signals are collected and analyzed so that the image can be constructed. Now the signals carry a topological, chemical and crystallographical information respectively of the sample surface. Next, the main applications are topography, the surface features of an object and its texture, that is hardness, reflectivity, etc. Morphology, that is the shape and size of particle making up the objects. Next, compositions and crystallographical information. And then looking to inside the column, that is electron gun alignment control, pneumatic air lock valves are there, condensed lens, objective aperture, scanning coils, objective lens, then motorized stage and sample chamber. These are the construction. Next, if you see, the main component are the sources of gun, condensed lens, electron magnetic lens, then electron detectors, also the sample chamber, computer display. The sources of electrons, that is electrons, is called as the electron gun. The function of electron sources is to emit a beam of electron with high density. So their types of electron sources are tungsten filament, solid state crystal, and third one is a field emission gun. Now the tungsten filament, that is a tungsten wire, it is heated to produce an electron. The tungsten wire is generally in inverted V shape. Now solid state crystals, so these solid states of various material, it produce high brightness image and having a longer life than tungsten filament. Field emission gun consists of a tungsten wire with a very sharp tip. An electron beam is emitted. By electron emission, the small tip radius produce the electron beam focused and improve the electrons emission. Now the field emission gun requires higher volume as compared to the harmonic emission gun. Next is a condensed lens. Now condensed lenses are used to focus electron beam at the contracting surface of the sample. Next is a electron magnetic lenses. So electron magnetic lenses are used to magnify and the demagnified diameter of the electron beam, and the change in a part of electron beam is achieved by electromagnets. Next is a electron detectors, which the number of electron signals are produced when the electron intersect with the surface of the samples, and of a specimen. Therefore the different types of detectors are used for different signals. In general, the most primary SEM is equipped with a detector of identifying the secondary electron signals and identify the image of the surface. At last, these signals is given to the computer, that is for displaying the image by using electron signals received by the detector and which provides the interface between SMA and operator. So next, how the electron beam is produced. The electron guns are used to produce a fine control beam of electron which are then focused at the specimen surface. The electron guns may either be harmonic gun or field emission guns. Now, electron beam sources. So these are the various sources as discussed, that are tungsten filament, solid state crystals, and field emission guns. The harmonic emission gun is nothing but the tungsten filament heated by DC to appropriate 2700 Kelvin or LFB6 rod heated to another 2000 Kelvin. Next, a vacuum of 3 to 10 to minus 3 Pascal is needed to prevent oxidation of the filament. Electrons buoyed off of the tip of the filament. Electrons are accelerated by an acceleration voltage of 1 to 50 kilovolts. Then field emission gun. The field emission gun consists of tungsten wire with a very sharp tip. Now the electron beam is emitted by the electron emission. Small tips radius improve the electron beam focus and improve the electrons emissions. The field emission gun is also, as discussed, it is a higher vacuum as compared to the harmonic gun emission. Next is a electron gun properties. These are the properties for electron gun. Next, why need of vacuum? When then in scanning electron microscope is used in electron optical column, and a sample chamber must always be at a vacuum. If the column is in a glass filled environment, electron will be scattered by the glass molecule, which would leads to reduction of a beam intensity and stability. Next, other glass molecules which could come from the sample, the microscope itself could be come from the components and condensed to the sample. This would lower the contrast and which details image. The major component of this is the magnetic lens. The magnetic lens is, as discussed, are used for magnifying and dismagnifying the diameter of electron beam. Also, it changes the path of electron beams in achieved by electromagnetic. Last, how electron beams are focused. The magnetic lens is a solenoid designed to produce a specific magnetic flux distribution, and where the lens formula is 1 upon F, which is 1 upon P plus 1 upon Q, and demagnification is M equal to Q upon P, where F, which is directly proportional to B, where F can be adjusted by changing value of B, that is a magnetic field. Lens formula and magnification objective lens is placed. Here the lens formula is 1 upon F equal to 1 upon O plus 1 upon J. So these are the various formula for lens and magnifications by objectives. Further information of the condenser lens. For the harmonic gun, the diameter of the first crossover point is near about 20 to 50 micrometer. If we wanted to focus the beam to a size less than 10 nanometer on the specimen surface, the magnification should be approximate 1 upon 5000, which is not easily attained with a one lens. only. So therefore the condense lens are added to demagnify the cross over the point. So the condense lens used to focus electron beam at a concentration surface of the sample. So I hope till here you have understood. So thank you. Thanks for watching.